chemical, like a water balloon would be, right? So the water is the chemical, same thing here. My chemical this time, though, is acetylcholine. So I have all these little balloons filled with acetylcholine out here. So I'm going to draw acetylcholine, that's that stuff. These are my vesicles. You draw it like that too.
How do you spell this?
Vesicles, yeah. Sounds like vesicles, right? Vesicles, whatever. Okay, here's my cell, my muscle cell. Over here, here's my cell. Muscle fiber, whatever you want to call it. It's all the same. Okay, now, I said there's a space between my nerve and the muscle, and here's a space right here, and actually it's called my, what should I call it? Synaptic cleft. Okay, so synaptic cleft. It's the space between the nerve and the muscle cell, synaptic cleft. Remember the sarcolemma? Cell membrane of my muscle cell? This is my muscle cell. Must have the cell membrane. Here is my sarcolemma. Okay, that's my cell membrane. Now, on that cell membrane, there's a special spot on the cell membrane where this nerve will attach to it. That special spot is known as the motor end plate. What you guys glad to do today? Motor end plates. Maybe there. So it's a cell membrane. Now, remember cell membranes can have like ion channels, and they can have all the other crazy protein things out there. Facilitated diffusion, facilitated transport, whatever. Okay, so on my motor end plate, I have ion channels. So I can go ahead and draw those in. Here's my little ion channel. Here's another one over here. Here's another one over here. So I'm drawing all these little ion channels. Yeah. Actually, these are sodium ion channels. I'm going to get really particular there. So, it's a cell with a membrane. What do I find a whole lot of on the extra side of the fluid side? I have a whole lot of sodium hanging out on the outside of my cell, right? That's that extra side of the fluid thing. Sodium, potassium pump the sodium out, put the potassium into thing. So, sodium on the outside of the cell membrane. We also have sodium hanging out over here, right? Here's my other side of the cell. So sodium's hanging out in my cleft, so things through here, all over the place. It's like floating in all this sodium. Okay. So what happens is, I have one more thing for you too. I have over here, on this motor end plate, I need a receptor for the acetylcholine. So I have little acetylcholine receptors over here. So I'll put those on here too. So I'll put over here ACH receptors. Okay, so here's how it's going to work. A signal, you're thinking about moving your hand or something, so it's skeletal muscle, it's voluntary, you have to have a signal going to it. So I think about moving my hand, a signal travels along my nerve all the way down to my synaptic end bulb. When I reach the end bulb, I release acetylcholine into the synaptic cleft. That acetylcholine fills up the cleft, and some of the acetylcholine will bind to the receptors on the motor end plate. Sound pretty good? Maybe okay. So acetylcholine swims to the other side. And once that happens, I activate sodium ion channels. Sodium then flows from outside of the cell inward. Remember my little T tubules that are found in my sarcolemma? Yeah, sodium likes to go through there too, right, to go deep inside the cell. So now I'm spreading that signal, right? So I'm spreading that signal with my sodium. That's that whole excitation, contraction, coupling thing, right? So I'm spreading the signal, I'm propagating it all the way through. So it goes through my little T tubules, across the cell membrane, all that good stuff. That's the sodium that travels through the T tubule to the terminal cisternae to play tag with calcium. Calcium's unreleased into SR, floods the thick and thin myofilaments, binds to troponin, myosin slides over, myosin left on, contraction. Let's start with that. What do you guys think? Good job. We'll come back, we'll do more.